to the second day of virtual faculty development program on predictive healthcare data analytics. With immense pleasure, I now invite Dr.Doreen keynote speaker, to take over the session. Please, ma'am.
Thank you. Thank you for your invitation, and we are into the second day of the workshop, or you call it as a program. All right, and it gives me immense pleasure to get connected with you. I hope you are all doing well. How are you all doing today? And happy Women's Day to all the women present here. If you all could switch on your cameras, kindly do switch on your cameras, please. All right. Okay. I could see Deepa ma'am. Yeah, there's a name as iPhone. I don't know. Maybe you can unmute your mics and say the name. Okay, people at different destination. We are all connected. Hope you are able to hear my voice. Yes, you are able to hear my voice. Okay, so today we are going to, yesterday we were started with what are the concepts that we have seen yesterday? Can one of you say? What are the concepts we have seen yesterday? We discussed or we worked yesterday? Yes, please. I want the session to be an interactive session. What are the topics or what are the content we discussed and we explored yesterday? That's my question. Yes? Anyone? Okay, we started with what is data analytics, and we were discussing about how many types of analytics?
4 types, ma'am.
Yeah, 4 types: descriptive, diagnostic, predictive, and prospective. And then we were discussing about where you'd be able to use your classification algorithm, where you'd be using your clustering algorithm and your regression algorithm. Supposingly, if you have a label data, that is when we have a target. Okay, when we have a target, then we say, when we have a target, then we say it's a labeled data. For example, disease present or not, it could be multi-label or a multi categories present over there. And then we moved on into when do you use clustering? Can we give you an example of when do we use clustering? When we do not have a target. Yes, tell me. When we do not have a target variable, we go on for clustering. That which means you don't have a labeled data. Wherein we don't have a labeled data, we go on for clustering. Then when do we go for regression? When do we go for regression?
When we have label supervised learning.
When we have regression, we go for supervised learning when the values is a continuously changed variables, maybe like a stock price or drugs, right? Drug responses, right? So for those, that is where, so before you go into analytics, you should be very clear when and how and why to use it. That's very important. When you should use it, how you should use it. Say for if you want to classify, then you go for classification. Want to predict for a particular category, you go for classification. You don't have a target variable, then what do? You are going to take content of it, right? You're going to cluster it. There are different kinds of clustering. According to your application, you should be very clear what algorithm. If your data set is going to have a continuous valid variables, then you go on for regression. Okay, and then what did we see yesterday? Do you remember what did we see yesterday? After this, after seeing the theoretical part, what did we start off with?
Some hands-on experience for pandas, ma'am.
Yeah, pandas. So what are the packages? Can you all put your answers on the chat? What are the packages that we have seen? You remember? What are the packages we have seen? We started with pandas. Then we worked with matplotlib.
Yes, ma'am. Seaborn also.
Seaborn. Missing numbers. Do you remember missing numbers?
Missing number Seaborn also, ma'am. Yes, sir.
Seaborn. And these are the other different visualization packages. We don't have time to discuss about this on this 3 days. Okay, if you want, you can take up a course therein. You will be discussed in detail fully. Okay, how are we going to work on with? All right, and then coming on into today, we'll be seeing about little about Plotly also. Today we'll be seeing little about Plotly. All right, Plotly is another visualization package. If you're making a note, you can make a note. These are the other different packages available. These are the other different packages available. All right. How many of you tried the kidney data set? And I asked you to load it on to the, what do I say? Load it on to the Google Classroom, but I have not got it. Okay. You can try to, 30 of you are into the Google Classroom. Okay, try to load it, right? Try to load what you have done. Okay, what you have done. So it will be easy for us. If you get doubts or something like that, it will be easy for us to clarify. It will be easy for us to clarify. Yes. How many of you worked and you have got the answers to what we've tried yesterday? You have shared the link. Okay. So Ruchi ma'am, you have tried. Deepa ma'am, I've got responses from two. What about the others? Okay, what about the others? How many of you have tried? Kindly give your answers on chat. Yes? You have tried? Yes? No? Yes? Only two responses I've got. What about others? How many of you are present now to the session? Can you type P on the chat? If you're present now for the session, just type P on the chat. Yeah, you've got responses only from few. Yes, yes. Getting responses itself is quite challenging, right? Okay, how many of you have worked it out? Only two responses. See, it is not only you listen to this talk. Don't think that you're just coming to this talk to get certificates. Yes, that could be one parameter or one factor of it. More than if you don't put your hands together and practice what has been done or what has been discussed, then it I don't know what to say about it. Okay, what to say about it. Yeah, everybody, we are a cube. We have got so much of work. Inspired SAIRAM Engineering College, the Department of IT, they have taken much pains to bring me into this. All right, and then to discuss about the content of it. But I want you all to get yourself involved. What we are going today, we are going to see the part of developing a machine learning algorithm. It's not a demonstration session, it's an hands-on session, right? It's an hands-on session. You're able to see my slides? Can you see the word quick game? Yes, no? Okay, can you see? Okay, before we start, we are going to start this with a quick game. You need to read, okay, the color of the word, not the word. See, it is written as blue, but you should not read it as blue. You should read it as red, blue, yellow, all right, green, black. And first you have to start from first to the last and then from last to the first. Are you ready to play? We have 26 participants right now over here. All right, don't think this will be the slide. There will be a next slide. You'll be given 30 seconds. Okay, and then after the end of it, I want one of you to unmute and share your experience. Listen carefully. You have to read from first to the last and last to the first. Not the word, but what do you need to read? Can you put your answers on chat? What do you need to read? Quick, please. Color. Thank you. Shall we start? Yes, we are going to start right now. Be ready. Yeah. Start reading it. Not the word, but you need to read the color of the word from first to the last and again from last to the first. Yes, 3, 2, 1. Okay, it's done. Okay, can one of you share your experience? How was it? Yes, please. You're able to complete it or you weren't able to complete it?
Ma'am, for me, the slide is not visible, ma'am.
Not now. It has been done before.
First time when you showed, yes, ma'am, done, ma'am.
Yeah.
Again, I did.
Now I stopped sharing it. Yes, how was your experiences? How many of you tried? Completed but little difficult. I don't know. You have given your name as iPhone. You can tell your name or post it onto the chat. Others, only one response. What about others? Yeah, thank you, Kalpana ma'am. Yes, what about others? Missing few. Thank you, Panjavarna ma'am. What about others? Yes, please. A bit challenging. Thank you, Belina ma'am. It's a bit challenging. All right. Let's give your answers quite quick. Then, completed, ma'am. It was difficult at the end. Okay. Slowly, but we are able to complete. Okay. Then, difficult for Durga ma'am, it's difficult. Okay, for each one of us it was a different kind of scenarios, right, that you have been because if it is word, right, it's very easy for us to do, because I told you you should not read the word but the color of the word. But you know, we know. Yes, please. Yes, you would like to share, Richard sir? Okay. So now we move on into our, so yesterday we have taken a data set. You remember we have taken kidney disease data set. From which repository we have taken the data set? Can one of you tell me? From which repository?
UCI, ma'am.
UCI machine learning repository. We have taken the data set from which, all right, and how many rows we had? 400 rows, you
400.
remember, and 25 columns. Yeah, and you have something called missing values. What is NAN? What does NAN stands for? On your data set somewhere you had got NAN, right? What does it stands for? Not a number. You remember? Not a number. Yes, not a number. And then what are the criteria we have taken to, see, listen carefully. Our objective is to develop a machine learning model that is going to predict whether the particular patient is going to have a kidney disease or not. Is the objective clear? See, our objective is to develop a machine learning model wherein you're going to find whether the particular patient has got a disease or not. Is the objective clear? Okay. And then what are the features that you're going to take? Age, blood pressure, specific gravity, albumin, sugar, red blood cells, fuzz cells, pus cell clumps, bacteria, blood sugar random, blood urea. If you're not speaking, maybe the
Dear participants, please kindly mute the number to speak.
Yeah. Yes, Saranya also, ma'am, you also could mute if supposingly, if mistakenly they are opening it up. Okay. And serum creatine, okay, the sodium, the potassium, hemoglobin, these are the different features. What is my target value? What is my target? Class is my target.
Classification.
So 24 features I have. Listen carefully. I've got 24 features and one target. And this target is a binary classification or multi-classification. My target is a binary classification or multi-classification.
Recording in progress.
It's a
Binary.
classification, because I'm going to
Binary.
check whether the particular patient is going to have a chronic kidney disease or not. All right, and then coming on to here, so here you have got the age, numericals, which is a new, so 11 numerical columns and 4 nominal, or you can say it as categorical. Age is a number, blood pressure is a number, okay, and a specific gravity, albumin, okay, RBC, okay. So these are the different, see here it is yes or no. Some of them they've got yes or no, and we have loaded it onto the data set, right? I hope most of you would have done it. Yeah, like Deepa ma'am and all, she shared that what she has done. Okay, you're able to see my screen. I'm not. And also I told you, supposingly if you have not come to the class or come to the session yesterday, you need to click on the file. And you need to join on to the Google Classroom, where we have shared the data sets for kidney, right? The data sets for kidney has been shared. And I will also share the link again. Like one person said that you missed your session yesterday. I do understand some of your invigilations or practical examinations are also going on. All right. And so I've given the data set here. Can you see? This is the data set, kidney disease data sets, right? Kidney disease data set has been shared with you, and that is what I showed you what will be the columns. So first load it on to your Google Drive. Then click on this file. Is my screen shared? You're able to see my screen? Can you type on the chat? Yes. Able to see my screen? Why the response is so slow? Yes, thank you. Yeah. So you need to click on this file icon, then click on this where you have got a Google Drive. Once your Google Drive is mounted, you'll get something called Drive here, and then click on My Drive, before which you need to download the CSV file. Please do not open, and upload it directly to your Google Drive, and upload it directly to your Google Drive, and your Google Drive should contain as kidney.csv. All right, and then when we come down, and when it is uploaded onto my Google Drive, can you see here kidney disease? Click on the 3 dots, and then you need to copy the path. All right. So first step, click on the file folder icon, then click on Google Drive, then you get Drive, and inside the Drive you have to traverse through and find out where is kidney, and you have to click the 3 dots and copy the path, and that is what you'll be doing. I'm importing pandas. You remember pandas is for data analysis, and we are using import pandas as PD. Okay, furthermore, instead of pandas I'll be using PD. All right, and then I'm going to use PD because my data type, my data set is of type CSV format, right? So PD.read CSV, all right, and then I'm uploading, and I've got the header files. How many rows? We have 400 rows and 25 columns, because sometimes all right, and we would have got head and tail. Head, what does head function? We have seen certain functions. What are the functions we have seen? Yesterday, those who have attended the session, can you tell me what are the methods that we have seen in pandas? You can also unmute and speak. What are the methods we have seen in yesterday's session in pandas? Yes, quick, please. Kindly do give me a quick answer. You're all faculties. Yes, you could really do. So we have seen head of function. What does head does? It takes the first few lines. How many lines? 5 lines from my data set. Tail takes my last few lines from my data set. And then what we have seen? What are the other methods? You remember we saw about describe of function, info of function, These are different methods. Okay, if you want to find a data type in Python, use type of that variable. So once I load my CSV, and if I'm loading into my pandas, the data type of pandas, right, is data frame. But I'm going to ask you a question. I see whosoever is going to answer it. What will be the type of the values of my data frame? What is the type of data type that carries the values of my data frame? If I give df dot values, what would be the data type? The values of it, numpy. NumPy. You remember yesterday we saw it's a NumPy array. See, I'm going to repeat it. When you take a CSV and load it into your pandas, the data type is converted into data frame. But the data type of the values that is inside my data frame, I repeat it, the data type of the values that is inside my data frame, it is NumPy array. It is NumPy array. Okay, it is NumPy. All right, and df.d types. So what we are able to find it out in this, as we are going into the analysis of data, we were able to see some of it which needs to have, okay, which needs to have the integer type, but it was showing as a object type. Do you remember which are the columns? What are the columns that had integer value but still
280
yeah,
out.
yeah, you remember? I'll show you now. Don't know. And every time you close up your Python notebook and you open up your Colab, you need to run it from the first, okay? Because Python is an interpreter language. Once the runtime gets disconnected, all the objects that is binded with the variables also will get disconnected. And you know, Python is purely a object-oriented programming, okay? And df.d types, and these are the data types, and you remember it. We have 400 rows and 26 columns, and these are some attributes. What are the attributes you've seen? Size, shape. You remember D types, columns, axis. Yes, axis. Yes.
Axis,
In dimension.
describe, info.
Yeah. When you have open and close parentheses, it denotes data frame methods. If there is no open and close parentheses, then it denotes it's an attribute. So this is an attribute. So 2 dimension, I told you, right? The values inside, but my data frame data type is data frame. Okay, but my values inside my data frame is a NumPy array. Okay, since I was not able to view all the columns, I made PD. That what does PD stands for? Pandas. That's set underscore options. Maximum rows is 999 and maximum columns I made it. So you know what is NAN. So when I showed you the data set, some columns were missing, some values, some cells were missing. It was so empty. So once it is empty, it is showed as not a number. What does NAN? It stands for not a number. So because I have an extra ID over here, okay, I have dropped it. This is one function, right? df dot drop off the column name. Y axis is equal to 1 because I want to drop my entire column. Axis is equal to 0 represents row. Axis is equal to 1 represents my entire column. In place equal to true. And after which, if I run, can you see the ID? No, the ID is not been there. And then what did we do? We rename the columns. Okay, when you have a square bracket, it represents the list. So df dot columns. Okay, if I'm going to use a normally if I'm going to use df dot column, you remember it was a attribute. It lists me the list of things, right? So, yeah. So df dot columns, I'm renaming every column. The parameters should be exactly the total number of column headers. Okay. So age, blood pressure. Before it was like this, right? You remember age, BP, SD, AL, SU. So we renamed all the columns to have more understanding of a data sets. To have more understanding of the data sets. And then we have 25 columns. Yesterday you tried info. What info shows? What is the data type of it? How many rows, how many columns? Now we have got 25 25 columns and 400 rows. And can you see you have 11 numericals and 14 nominals, 14 categorical value. Can you see here? I showed you on the data set also. You remember this? See 11 numerical values and 40 nominal values. Can you see on the analysis here? Can you see on the analysis here right now? There were 14 float
Yes, ma'am.
values and objects, right? So now for do a descriptive analytics, you df.describe of. So df.describe of what it will take? Because my data set contains both integer values and a categorical value. So when I say this normal and all belongs to a categorical value. So once I use like describe of function, it only takes the column, listen carefully, it only takes the column that carries numerical values. Only for those columns alone describe function will work. Okay, you cannot see describe function for red blood cells and fuzz cells. Can you see here? Can you see red blood cells and fuzz cells? No, you cannot. You cannot see. Only the variables that contains here, whatever is float. Okay, whatever is float or integer, only to that you can do. So what are the functionalities it does in one function? The count of function. Okay, how many values are there? Okay, so from this itself you'll be able to find out your data set has got missing values. All right, you're able to figure it out. Your data set has got missing values. It takes the mean of the entire column, the standard deviation, the minimum, top 25. What is 50%? Can any one of you say what is 50% of it? It's the median. It's the median, then 75%. And what is that? So in this data set, when I see this column, if this data set has got a people of kidney disease starting from age 2 till 90 years. This is what you get an inference from description. You're trying to describe. So what is the minimum blood pressure in this data set? 50 and the maximum is 180. And blood sugar level, can you see? The minimum is 22, maximum is 490. It's serum. So it's serum creatinine value 76 is a creatinine value. All right. Hemoglobin from 10 to 17. So in one functionality, you are able to find it out. Any doubts till now? And then here we have used like drop function, head of function, tail of function. And then you remember yesterday we used 2 numeric. Okay. Why 2 numeric? These values, what are the values? You remember what are the 3 columns? Packed cell volume, white blood cells and red blood cells. Okay. Okay. Packed cell volume, white blood cells and red blood cells. They're looking like object. Can you see these 3? Can you see? It is because it was not having it, the type. We need to do the typecasting. That is what you also would have not seen on the describe function. Packed the white blood cells and red blood cells. Can you see on describe function? Can you see white blood cells? Okay, if you have run, you cannot see because the column name has been taken as an object. So what we need to do? We need to do typecasting only till hemoglobin it came, and then we use this function called to_numeric. When you see age.unique, you cannot see the apostrophe right on the values because it is taken as integer. But when you see packed cell volumes, can you see an apostrophe on the top? Yes, which means it is taken as an object. So as a data scientist, what you need to do? You need to typecast it. So I'm using this function pd.to_numeric, like pd.to_numeric and df.plug_cells and errors COERCE. Why this? I'm giving this parameter. If there is no value, it will default take it as not a number, because some cells were empty. So for that I'm using these parameter. Now if you could see packed cell volume, white blood cells, everybody they are into float. Now if I'm going to use, listen carefully, if I'm going to use, last time when I used df.describe of, it was only till hemoglobin, but if I run now, okay, even after hemoglobin I will be getting, can you see, packed cell volume, white blood cells and red blood cells. Yes, able to understand till now? Okay, then we tried working with Then we splitted our columns into categorical columns and numerical columns. Okay, categorical columns, the columns that contains numbers, and numerical columns, the columns that contains, sorry, categorical column, the column that contains the strings, and numerical columns that contains integer. And how many unique values? Remember, we saw this function also, unique and n unique of. What is the difference between unique and n unique of? Can one of you say? What is the difference between unique and n unique of? Yes. Unique of will tell me what are the unique values. Okay. And n unique of will tell me the total number of values. Okay. See if I'm going to give df dot n unique of. Can you see how many unique values are there? Age has got 76 unique values. My class has got 2 unique values. Okay. So when I'm going to list my categorical values and the unique values, because of this analysis, I'm able to find I need to clean this data, \t, /ts, /t, and here. So I'm going to use another function called as to replace of. How many of you have tried replace? Not getting responses at all. Kindly do respond, please. Yes, you all tried?
I have tried, ma'am.
Okay, thank you, Deepa ma'am. Okay,
Ma'am.
yeah. Dot replace of, and I'm passing a parameter dot to underscore replace, and t no is been no, and ts is yes, and s is yes, because there was a space between. So you should be very carefully figuring out what are the discrepancies in the data, because you're going to see, can you see here? There was an extra space that also need to be curated. So that is what they are curating here. So the first step, we have to load the data analysis, and then we have to do the curation, and it has been done. And then the next method, we use mapping CKD to 0 and non CKD to 1. All right. And now this is also converted to be an integer. We have mapped the class also to be as integers. How many of you have completed till now? Any doubts? Or is just listening? It's hands-on session. It's not a listening session, please. If you are having doubt, kindly unmute and ask. I'd be able to figure it out. Yes, please. How many of you mounted the data and tried till this? Yes. I got response from Deepa ma'am and Suruchi ma'am. Yeah, Panchavarna ma'am. What about others? Any difficulties you find? How many of you have tried it? Okay, I'm going to ask you another question. How many of you mounted the database into the Colab? If you mounted the data set into the Colab, type yes on the chat. Please do respond. If you respond only, otherwise it will become like a seminar or webinar. I don't want that to happen. Deepa ma'am says yes. What about others? I want the answers quick on chat, please. Yes. Yeah, Shanti ma'am, you said yes. What about others? Either say yes or no. Hello. Okay. So now we have seen what are the unique values, right, in diabetes, and after we have curated, before you can see, if you want to make a note of it, kindly try it out. How many of you have completed replace or not completed replace? Okay. I'll give you time to work it out. Kindly please do work it out. Okay. Kindly do respond, please. Okay. And now we have curated the values. And now yesterday we started with the visualization. And how many of you tried this count plot? Import Seaborn as SNS and count plot. How many of you have tried this? I want the answers quick on the chat, please.
Me, ma'am. I have tried, ma'am. I have tried.
Yeah. Deepa ma'am, you shared it, so I saw. What about others? How many of you got this point? Yeah. Kalpana ma'am, thank you. Yeah, Shanti ma'am, thank you. What about others? Kindly respond yes or no. Okay, so it count plots. What it does the value counts. What it does the value counts. Okay, value counts. So that is what it is being shown over here. It counts the values and it sums it up and then it brings it. Okay, and sums it up and that brings. So what is a functionality that runs behind a count plot is called as value underscore counts of. It counts how many zeros, how many ones, and then it gives me the answer. Then it gives me the answer. All right. So here in my data set, I could infer 0 means the patient has got a disease and 1 means the patient doesn't have a disease. All right. And the number of patients with the disease are more in comparison with the patients who don't have disease in this data set. Okay. And also you can use different color palettes we were seeing about. Okay. And here if I'm using a palette like rocket, I'm going to take one column name, coronary heart disease. So in my entire data set, only few have got heart disease, others they don't have heart disease. And I'm giving only my X value, my data is equal to DF, palette is equal to rocket. If you have not tried, kindly try this. Once you have tried it, onto the chat, post it as done. I'm giving one column name and it is case sensitive. And data is equal to the data frame, palette equal to rocket. Can you try now? See, we started with plotting yesterday. Yes, please, can you quickly try? Once you have completed, put on the chat as done. This first thing was what the classes, that is with the output. And the second graph, we didn't give a palette, it took the palette on its own. Now I'm giving a palette name as rocket. Yes, please. Waiting for your answers. All right. Make it fast, make it quick. All right. Okay. So I'm giving one column name and there I'm giving only my X is equal to what is my column name, what is my data set, and my palette is just for visualization of color. You can find the difference between this color with a default. This is the default one. Okay. And this when I give a, there are different palettes, you can find it out like sns.color_palette of. All right, and now see the same function, and here I am giving hue. Okay, what is my hue? Always mostly carries the target variable. Okay, what is my target variable? My objective is to develop a machine learning model to predict whether the particular patient is going to have a disease or not. Okay, and here my hue is my class, and what happens, the same thing, only I've used this parameter hue. When the patient don't have a disease, don't have heart disease, and then those who have got kidney disease is more, and those who don't have heart disease but they are not kidney patients, they are not kidney patients. Can you see here? They are not kidney patients, but those who have heart disease have kidney problem, but there is no one who has a heart disease and doesn't have a kidney problem. They have a kid, there is no one, right? No person is there without kidney disease. If they, so we can take a rule, if they have a heart disease, we can say it has got a very strong correlation to them who has got a kidney disease. What are the other inference that you can come out from this? If you could answer up, it will be a little more interactive and it could be good. Yes, yes, please. All right, now I want you all to take another column name, any other, there are so many column names, right? But see, when you use n unique of, you know how many x values are there. Okay, how many you cannot plot like 146 you can plot, but rather we need to set up the figure size. Okay, same thing you can use it for red blood cells. Okay, this is coronary artery. Can you try for red blood cells? Can you try now? I want you all to try. And this is another palette called Macro. And also there is something called set 2, set 3. Let me give set 1. Check whether it works. Yeah, it works. So red blood cells, normal blood cells, abnormal blood cells. So when you have a red blood cells, it is abnormal, mandatory the patient is having kidney disease. When it is normal, only a few have normal blood cells and they have a kidney disease. And if it is normal, predominantly most of them, they do not have a kidney disease. So you need to write inferences. You need to write inferences. That is the main objective of exploratory data analysis. As I've tried this, can you try it for any other column name, please? But ensure the number of unique values are less on the x-axis. I want you to try right now and give your answers on chat. Which column we have taken? All right. Which column you have taken? Yes, please. I hope you are all trying. Like set 1, I've given, you can also give set 2. Okay, the color only changes, like palette, macro. Can you find the difference? Like palette, macro, or a rocket? Are you all trying, please? Try for red blood cells, or you posted on the chat which column you tried. You have taken PCV. Thank you, Suruchi ma'am. How many columns are there in PCV? 42, which means it should be bigger. You need to set up the figure size. So when you take columns which has less number of unique values, maybe specific gravity. I've taken hypertension, diabetes mellitus. So that is one ground rule you need to see. I am taken for hypertension, but the palate is macro. So if there is hypertension, mandatorily they have a disease. When they don't have hypertension, also they have kidney disease, but the number is less in comparison with people with non kidney disease, non CKD, and also there is no hypertension, and also there is no hypertension. So you need to write the inferences. Okay. What are the columns you all tried? Or a silent listeners, or you switched on the system and you traveled back? Only one response I've got. What about others? Yes, please. All right. And when you want to try, you can see the different color palettes, set 1, set 2, set 3. Okay, and as you give different sets, you'll be able to find it out, the color changes. I told you, right? Set 1 was a different color, set 2, set 3. All right. And yeah, SNS.com plots, you have done it for first cell clumps, first cell clumps. So if it is present, which means the patient mandatorily has a kidney disease. If it is not present, it is less in comparison with those who have got a kidney disease. The red blood cell count, I told you, right? If the number of values are more, then your graph doesn't look, you need to go and set it up your figure size. Okay, we need to set up the figure size. Now in this data set, in my data set, now listen carefully. We have seen if this data set has got missing numbers. So when you take a data set from UCI machine learning repository, okay, there'll be one thing: how many attributes, how many instances, multivariate, real, classification, right? And can you see it has got missing values? So with missing values, you cannot develop your machine learning. Even one cell also should not be empty. Okay, so before we move on to finding out the missing values, we are going in for visualization. So the next package is missing number as MSNO. Okay, and then give MSNO dot bar of DF. Try it out. And you can see from my entire data set, only the class has got 400, others it has got the least is 248. Okay, 248 is the least. Red blood cells has got more missing values. Okay, can you try this now? Import missing number as MSNO and like MSNO dot bar the data frame. The data frame. Try it out. Once you have done this, it's very simple. Put it onto the chat as done. Okay. Are you all trying? Let me wait. Yes. How many of you have got the bar graph? Thank you, Suruchi ma'am. What about others? Only one response, I've got it. Others are all trying. See, if you have got even 1 lakh or 2 lakhs or 20 lakhs of data also, you will be able to do it. Okay, you'll be able to do it. Okay, the first function in missing numbers, we have used bar graph to visualize. And the next is the matrices. So wherever you see like it is white, those rows, so from 1 to 400, those rows are empty. Okay, and when you see in class, there is no row that is empty. Every values are present. All the values are present. Now try msno.matrix. First we tried bar of df. Now try msno.matrix of df. Try it out quick. Yes. Only one responses. What about others? Are you all trying? msno.matrix of df. All right. Okay, keep trying. You have to import missing number as MSNO. If you are using MSNO, the same MSNO alone you should use. Only 2 responses I'm getting right from yesterday, only from Suruchi ma'am, Deepa ma'am. Okay. Yeah, with the mobile you'll not be able to do it, ma'am. Okay. And the next is msno.heat maps. So using heat maps, you'll be able to find it out, the missing values, right? So when you cannot see class at all, how many number of, okay, msno dot, it takes the correlation of it and finds out the missing values. msno dot heat map of df. Try it out. The time is given to you so that you'll be able to practice it. You'll be working on with that. If you have got any errors or something like that, I mean, you can let me know. Jesus. How many of you are able to follow it? Answers on chat as F. You can put it on the chat as F if you are not able to follow it. If you are unable to follow, type U on the chat. Okay, once you have an hands-on session, these are some visualization to figure it out whether you are able to find how many missing values are there. For that package only, Python is giving you, which is called as missing NO. There are so many packages in Python. This is the package in Python. Can you see? This is an simple to use Python package for finding out missing numbers. Okay, and where is the presence and how is the representation of data in a data frame. Okay, it can be in bar plot we have seen, matrix plot, heat maps, and also dendrograms. All right. Okay, so now if I want, I told you, right, if the size is not correct, then you can have a size plt dot. You remember matplot lib dot pyplot as plt we have taken yesterday, and the figure size I can give. See, you remember that what one of the plot was very clumsy. Yeah. And you can give it as PLT dot show off. Then the same graph, you get it onto a bigger size. Can you see now? The same graph, it was too clumsy. You remember I told you before, you have to if your x-axis is more, you need to define your figure size. You need to define your figure size. PLT dot figure, comma, open parenthesis figure size, which is equal to 20, comma 15. Then give whatever plots and then give PLT dot show. Supposing if you have taken, try this now. Try this. Try it out. You take one column where in n unique of the number of columns or more, or even take the same thing, red blood cell count. Only set 1, set 2, set 3, or you can have it as rocket or NATO. Yes, try it out now. You define a figure size and then PLT dot figure of figure size. What is my x-axis? What would be my y-axis? And I'm using whatever plot. It could be different plots we are going to try now. We have taken into the count plots, and the hue and the data is equal to DF and palette is rocket. All right. If you have tried this, put it onto the chat as done. Okay, waiting for your responses. If you have got any doubts, feel free to unmute and ask. Yes, please. Have you got it? A bigger visualization like this? If not, it was too clumsy. So when you have got a bigger graph, you need to define your figure size. Are you able to understand till now? If you're able to understand till now, answers on chat as Y. If no, give it as N. I want everybody to give an answer on the chat. Those are connected today. If you're able to understand, give as yes, Y, or if you're not able to understand, give as N. Saranya, yes. Deepa ma'am, yes. What about others? Yes, please. Only 2 of you are listening to the talk. Yeah, beautiful Deepa ma'am. You have got the matters also. Yes, there are 2 one is Sarada, one is Saranya. Okay. Only 3 responses out of 28. Others you all switched on. This is a good figuring out by the coordinators to check how many of them are really connected. I want those who are attending to this talk right now, if you're able to follow, put Y on the chat. If not, put N on the chat. Quick. Quick. Yes, Karthikeyan sir. What about others? Only 4. What about others? You're connected or you're not connected? Okay. You know, we have taken so much of time to come and meet you today through this platform. I want you all to be responsive. Okay. I want you to make the good use of it, not to waste whatever we are going to do it, right? It's not a time to be wasted, right? Okay. And then you're not going into this right now. Okay. Now we are going into heat maps. Okay, listen carefully. What heat maps does, yesterday during the start of the session I said, here using data science you'll be able to find correlations of data. You remember I told correlation, how we'll be able to correlate your data. Okay, you'll be able to find, can you remember? It finds various correlation. This Python provides like Pearson's correlation, Kendall's correlation, Spearman correlation. But default, when I use the dataframe.co or CORR of, okay, it performs the Pearson's correlation. It performs the Pearson's correlation. So now the correlation, when you want to visualize it, okay. So before moving on to that, I will open up. Okay. df.core of, okay, the core is what? CORR, df.corr, it finds the correlation. Okay, the same thing is correlated, but I am showing it onto a heat map. Okay, this is the function that happens. Say for example, if I want to do it, df.core of class. Okay, so what is my target here? What is my target here? My target here is class. Class is my target. So if I'm going to listen carefully, df.core, when I'm going to use this function, it computes a correlation. How age will be correlated with age? That is strong correlation 1. Blood pressure with blood pressure 1. So when you see on the correlation on the diagonally, it will be 1. Okay, diagonally it will be 1 because Doreen can be correlated with Doreen. It's 1, highly correlated, right? So the same features to be correlated will be 1. All right, but how far it is going to get correlated with your other features? You remember yesterday we saw about X contains the feature, Y contains the target. Okay, so if I'm going to use this function CORR, okay, CORR is the function. Can you see there are different correlations available, but default it takes Pearson's correlation. Okay, and also it provides Kendall's tau correlation coefficient, Spearman's correlation. Okay, Spearman's correlation. But here I'm using Pearson's correlation. Default it is Pearson's correlation. Okay. So what do you mean if the value is negative? What do you mean when the value is negative? What do you mean when the value is positive? You can see some values are positive. Can you see here? My thing is all the features, this column is more important. How far it is correlated with my target. Okay, some are positive, some are negative. Can any one of you say what is the difference between positive and negative values on the correlation, please?
Highly correlated indicates 1, ma'am. And there is no relationship means it will be negative value.
Yeah, rightly said, Deepa ma'am. Your answer is right. So, age, because of age, I'm going to have a correlation with my class. Yes, age has got correlated with my white blood cells. Age has got correlation with my potassium, but serum creatinine, the blood urea, the sugar, yes, but with the age, with my target, the correlation is less. So from which you will be able to work on with a feature engineering. Say for example, here we have got like 25 columns or 25 columns. That's fine. Sometimes if you have a data set where you have 75 columns or 80 columns, you need to take it up only for those wherein you have got your highly correlated for features. That features will be taken and a new data frame could be generated with those columns, all right, and that could be taken for your developing a machine learning model. So we can drop which are those which are negatively correlated. We can drop columns which are negatively correlated too. All right, df.core of, okay, this is the function. So if I'm not going to give any column names, it is going to do this value is one. I'm going, because what is my objective? What are the features that are highly correlated with my target value? Okay, I want to know which are the features that are highly correlated with my target value. What is my target value? Is my class. So here I can see specific gravity has got a good feature. Okay, sodium, hemoglobin, packed cell volumes, and red blood cell count. Able to find it out? Okay, you are able to find it out. So, and that I'm going to show it as a heat map like this. Now I want you all to try. Okay, plt.figure, a figure size. I'm going to define what is my size of the figure. What is the size of my figure? Okay, and 15 on the x and 8 on the y. Using cbond sns.heatmap, I have to send this function df.core of anode is equal to true. Can you see here the values? If I'm not going to give anode is equal to, line width is the width of this line and the line color is gray. Can you see it's separated by gray? See, if I'm not going to give anode equal to true, and if I'm going to run it, just see, I'll get an heat map with the color. Can you see? With the color I need to, so if it is highly correlated, I'll get a light color. When it is negatively correlated, I get a very dark color. Can you see now? Can you see? Hello? See, this diagonal is highly correlated. It's one, the lighter. The darker, it is less correlated. So if I want to know the values, what is the values in it, I go on for annotate equal to true. So annotate equal to true helps us to have the values on the heat maps. Okay. The line width, and also if I give a line width of more, see, if I'm going to give line width of 5, you can see there will be a bigger space on my heat maps. Can you see? Can you see the size is bigger in comparison with before? That's it. And the light color, the line color is light gray. So now try it out. I'll give you time, during which if you have got any errors or any doubts, please feel free to unmute and ask. Yes, please. I hope you're all trying. Okay. First figure size 15,8, x-axis and y-axis, and sns.heatmap df.core of annotate equal to true, the line width and the line color. I can give black or whatever it is I've given here as light gray. Yes, you're trying. Thank you. What about others? You have 31 people here. Are you all
Fine,
trying?
ma'am.
So many of you are here. Kindly do try. It's an hands-on session. The more you work it out, the more you'll be able to learn from it. It's not a webinar. It's not just a talk to sit, listen, and go. You know, so many commitments today. I'm inspired. College, they have the Department of IT has taken steps to bring me and connect with you to work on it with. If you're going to simply sit and without doing it, I don't know who will be the losers, right? I want you all to try it out. If you get error, please feel free to share and ask me. But don't sit idle or don't switch on it and just leave it out. Don't think you've got recordings post which you'll be able to read it and know. No, you don't get time. Yes, once completed, let me know the heat maps. Can I move on to the next? Okay. Okay. Now we are going to go into another function like count plot we have taken. Now we are going into another plot called violent plot. Okay. Okay. And for this, I'm going to import another package called as import plotly.express at px. Okay. The next package that we're going to say, I told you about plotly, right? Plotly.express, okay, as ps. So what is this package? This is the package. I hope you're able to see my screen on plotly python. Yes, hello, you're able to see my screen on plotly. Okay, so plotly.express, okay, plotly.express, like I'm using as px, okay, px.bar, x-axis abc, y 1 2 3, and I can write it as an html. I can make it auto open also. Okay, this is very simple. So plotly is generally dash is another chart. We are not going to dash now. Okay, it's for analytic applications, right? To how to run applications like this. As you hover over, can you see the values onto it? Can you see x-axis, y-axis? It's kind of an interactive application, like a, what is a value, and y, what is b, x and y value. Okay, it's very simple, right? So this is one of very simple example for plotly. Okay, we have to import plotly as px, plotly.express as px. See, I've already imported it, so I'm not going to import. Figure is equal to this variable, figure px.bar of abc. Okay, y is equal to what would be my x and what would be my y, and I'm figure, because I have made the setting of figure size for my heat map before. Yeah, I will resize it now. So what is my size? I can make it as 7 and 5. So first, once you set up, the other graph also comes to that size. So now I'm resizing it to 7 and 5. Okay. Can you see it's reduced? A, B, and C. Can you see the interactive? As I hover over, you are able to see it's produced with plotly. Okay, I can auto scale if I want to make it small. Okay, it's totally an interactive one. It's an interactive one. So same thing. Now I'm going to try and another plot called violin plot. Figure is equal to px dot violin. Okay, what would be my y? Red blood cells count. What would be my x-axis? X-axis is classes. Okay, template is plotly dark. Can you see now what is a dark template? Dark, and then figure dot show. Figure dot show. So now I'm going to show you this, and also box is equal to true. Can you see the box? It shows the kernel density estimate. So as I hover over, can you see the values of values keeps changing? If the class is 0, what is my red blood count when they have a disease and when they don't have a disease? Okay, box is equal to true, and plotly has got different templates. Plotly has got different templates. And one such template is plotly dark. And also you can see what are the different theming and templating. Okay, theming and templating with plotly. Thank you, Deepa ma'am. So there are built-in themes available. PIO. It's plotly, like available templates are like Seaborn or Simple White. Can you see here it's plotly underscore dark, and also there is something called plotly underscore white or plotly. Okay. If I'm going to give, instead of dark, I'm going to give white. Can you see the difference here? Okay. Now we are going to okay. Will you try? Either black or white. Black looks even more darker and it was neat. There are different templates that you could use it. Plotly underscore black. And it's case sensitive. If you give a wrong value, then you get an error. Okay, should be very correct what they've given, and even if it is a small error, also it doesn't work. It's not plotly black, it's plotly dark. Are you all trying this? Can you find how interactive it is? Can you give me a response, please? I've got one response trying. Yeah, please do try. Only one response I'm getting. What about others? Import plotly.express at px, then figure px.violin of, give the data frame, y-axis what you want to have, and axis classes. Okay. If you have got it, kindly put on to the chat. Yes. Yeah. How many of you have got the violin plot? Can you give the answers on chat, please? px.violin. And also, once you have tried, try to change any other x-axis, got an error. What's the error? I have shared it on the chat. Yes, please. Yeah, I could see what the heat maps. Are you trying it? You are using Plotly. Using Plotly, you get an interactive which has a hover mode. And when you're going to develop your web applications, yeah, thank you. When you're doing your web applications, right, it will be very useful for you. Maybe today afternoon before we start a session, I'll try to show how you'd be able to do what do I say, interactive web page for this. A very simple tool. I'll try to teach you. Right, I can show a demonstration. I don't know whether I'll be able to teach you. I can show you a demonstration. Then you'll try to understand why do we do that. All right. And now, since we have completed, the next plot is, and I want you all to try post which the class for different other columns. So next. What we are going to do is that we have tried the violin plot. Now we are going in for the scatter plot. Okay, we are going in for the scatter plot. Px dot scatter df. You have to give the df. What should be in my x-axis? X-axis I'm giving hemoglobin. Y-axis, I'm giving packed cell volume. Okay, and what would be the color? The color is the class. What is my class? Whether the CKD is present or not. And template is, can you see as I hover over, you're able to see. So here the class is 0, which means they have got disease. So people who have got chronic kidney disease, generally the hemoglobin level is less, and this is class is equal to 1. People, they don't have chronic kidney disease, or they have the hemoglobin level high. So this is an example, and also you can also box into one scale and find it out. Okay, and also if you want to have a lasso select, that also could be done using it makes you more interactive. Okay, can you see? If you want to move only with a section, you can go on with that, right? So this is what these are some advantages of using Plotly. PLT, give it as, I'll just zoom it a little bigger. You can find it out. Yes, px.scatter df, and give what here you can give continuous values onto the x and continuous values onto the y, because it is going to be scatter plot. There you give hue. Here I'm giving color is my class, and my template is Plotly dark or Plotly white or fig dot, and then you have to go in for fig dot show. Can you try this now? There are 31 people, but only one response. I'm getting 1 or 2. I wish you all to try, work it out, and then give your responses on chat, please. At least for this. Try it out. If you have got errors, you can get it done from me. But I want you to try it now. Okay, have you got it? Keep trying it. Keep trying it. Don't be idle, or don't open it up and then move away. If you have got any errors, kindly let me know. Please do. Please do try it out. Okay, and also you can give any continuous variables on the column features, any of the features also. Yeah,
Done, ma'am.
thank you, Deepa ma'am. Only one response. What about others? Other than Deepa ma'am, I'm not getting any responses. Okay. You're trying. Thank you, Shanti ma'am. I'm happy at least 2 of you are giving me the responses. Kindly don't waste the time. Let's see, I can show how Deepa ma'am has got the responses on scatter plot. She has taken hemoglobin and PCV onto the Y. And yeah. What is the error? You can find it out, ma'am, and then share it. So it's very simple and it's very case sensitive. Just give the data frame. What should be on your X? What should be on a Y? What is your color? And template is what you want to have. Even if you don't give a template, let's see what happens. Okay. I'm not giving any templates. It will take its default one. Can you see? I'm not given templates. It's default. It's white. Okay, plotly of white. So if you want, you can give, or also even without template it works. Okay, even without template it works. Able to understand till now? Okay, you have done. Thank you. Only 3 responses. Okay, out of 31, only 3 of you are working. Okay, next we have seen, what are the graphs we have seen? In Plotly, we have seen violent plot. All right, next we have moved on to the scatter plot. So even whatever you learn it thorough, and then we moved on into a, now we are moving on to a bar, right, into a bar plots. Take px dot violin, px dot scatter. Now we are going for px dot bar. Data frame x, I'm giving the blood pressure. What are the different values of blood pressure from 0 to 140 till 180, and the color, when it is white, yellow color, it is they don't have a disease. So they have on to their x-axis the blood pressure is between 60 to 80. They don't have kidney disease. Once the high blood pressure, then they're prone to have a kidney disease. Then they're prone to have a, see, even 180, you can see 180, and the hemoglobin is 11.2 and the class is 0. And also you can see the color intensity of the class between 0 to on the color scale. All right, and I've given the height here, and also you can give the x-axis also, right? Can you try this? Px dot bar, x-axis, y-axis, color. The bar mode I've given it as group. Here I'm going in little more depth. The bar mode, how is I'm going to group it like 0 to 60, 60 to 80, and up to 220. It takes the minimum and maximum and does the bar. Okay, and does the grouping, and then it shows. Keep trying. It's this px dot bar of df is the data frame, x is equal to blood pressure, any one of the column, y is should be the another column name. Okay, and then what is the color is the class. Okay, my target, right, generally that will be the color, and I'm grouping. It's a bar graph, so I'm grouping my bar mode as group, because you've got a scatter plots, it's okay, right, because you've got so many values and you get a scatter plot for each point. But here I'm grouping for a bar graph, so the bar mode is group. And template, I'm using plotly dark, and what is the height of the, and also I can also define the width. Okay, maybe width equal to something 500. Let me
Done, ma'am.
done. Thank you, Deepa ma'am. It gives it also, I didn't give a comma over here. Okay, can you see when I decrease the width, it's smaller. All right, so you can also define the width and height here also. If you want to have it on a shape, let's try for scatter plot. If you want to extend, you can also extend it. Okay, before it was too big. So here itself you can give it out. Try with the width and the height. Can you see now? As I hover over, you'll be able to see. What are the median Q3, Q1, quartile 1, quartile 2, quartile 3. And if they don't have a disease, the red blood cell count is higher. When they have a disease, they have got a lower blood cells count along with your class. Yes. Thank you, Deepa ma'am and Suruchi ma'am. Okay. Okay, any doubts till now? You're able to follow. We have seen 3 different plots: the bar, the scatter, the violin. Now we will move on into the other plot called as facet grid. Okay, facet grid. Okay, I'm going to give my data frame and my class. What is my class? Whether they have got a CKD or not. What is the height and aspect? And then I'm going to map that facet grid. Okay, the facet grid to my KDE. KDE plot stands for kernel density estimate. Okay, it's visualizing how the distribution of data is there all over your data set. Okay, all over your data set. It uses the continuous probability density for curve. Okay, from 1 to 1 dimension. And I'm going to add a legend. So my red blood cells, it starts from 1 and it goes up to this. And if they don't have a disease, how does my red blood cell count work? Okay, I'm going to use 2 functions. One is called as facet grid and the other is what is the other one? That's the kernel density estimate. So how the distribution of data. So you can see how you can go into cbon, right, .pydata.org, where you'll be able to find the more functionalities of different visualization. Multi-plot grid for conditional relationships. So this is how is called the facet grid works. Okay, first you get for the tips, and onto that you give your columns, and then you go on for a scatter plot you have for conditions. So here what I'm taking here on my facet grid, I'm taking my total df and my hue. Okay, and on what is the height and what is the aspect I need, and I'm mapping that because it's relationship on a conditional relationship, and I'm going for s dot KDE plot. What is kernel? So how far is my distribution of data for a particular parameter, right? Red blood cells. How is the density of this value of red blood cells count to find it out? Even violin plot also uses the kernel density estimate. Can you see when the violin plot is little bigger? So here the density is higher, the kernel density estimate. Okay, here I'm going to show you a facet grid along with the KDE plot. Able to understand? I'm in facet grid, I'm passing the data frame. What is my hue, the height and the aspect, and SNS dot KDE plot. Okay, the KDE plot. So kernel density estimate plot has been taken, and only for one column variables, that is red blood cell count, and I'm a grid dot, I'm adding the legend to it. That's it. Okay. It's not plotly, it's the normal cbon. Can you find the difference between the matplotlib, the cbon and the plotly? Plotly it's more interactive. Plotly it's more interactive. Can you try this now? Kindly please do respond. You're able to follow? Only Deepa ma'am and Suruchi ma'am, I'm getting response. Others also, please feel free to share. If you've got doubts also, let me know. How many of you are connected to this talk? Put down to the chat yes. How many of you are connected to the session right now? Put down to the chat yes. Guru Sharvan sir, are you trying? Yeah, Shanti ma'am, I'm getting some time. Your response, I hope you're also trying. Balagita ma'am, if you don't try, it will be difficult. All right. Thank you, Karthikeyan sir. Got an error? Keep trying. It should be within the quotes, single or double quotes, and it's case sensitive. Others are all trying. Kindly open colab.research.google.com. Connect on to the Google Classroom where the content has been, data set has been given. Yeah, Suruchi ma'am has posted. I've given an assignment, not an assignment, as what you're doing, right? You can post it onto the as an assignment. So I'll know how far you're doing on your collab, if you're getting an error or not. It'll be quite easy for me to figure it out. Okay, it will be easy for me to figure it out. So you can see how Suruchi ma'am has worked on. She has correctly mounted onto the data set. I'm showing the pages of Suruchi ma'am, and as and why how she works, I'll be able to find it out here. Yeah, she has worked on the missing numbers and the plots, and she's trying now. Thank you, Suruchi ma'am. I can see your Python notebook. This is the best takeaway of this workshop. Okay, it has been assigned for 30 people, but if you are not going to use it, I do not know what to say. We have taken off our time and come to share it with you. I want you to use it. Okay, I had even 3 more events for this day, their invitation, but still the college has booked me even before 3 months, right? And they want to do the best for it. All right, and I want you to take the best takeaway. It's not only listening to it or getting only the certificates. Once as a faculty you get yourself trained, through you many students will be trained throughout your lifetime, and you'll be a blessing for many. And nowadays students, they are so smart, and we need to be even more smarter than them. Yes, have you done with the facet grid? It's for the relationship of two. Okay, the class and with the KDE, the kernel density estimate. Yes, thank you, Suruchi ma'am. What about others? Are you getting it, or shall I move on to the next? Okay, we have tried it out, the kernel density estimate. All right. And then we have tried the violent plot. We have tried the scatter plot, the bar plot, and there are still many plots are there. Okay, we are not going too deep into it. And now we are going to find, is there any missing values, right? Is there any missing values available? Okay, the functionality. See, df, find it out, df dot is null of dot sum of. So is null of is going to show me whether I'm going to have any null values. Okay, df dot is null of dot sum of. Okay, so my data frame is in df, right? My data frame is in df. So df dot is null of. Is null of, it is going to find is there any column that contains is null of. Dot sum of is an aggregate function. It sums up all the columns where it is empty. Sorry, not all the columns, all the cells where it is empty. So in each column, how many missing numbers I have? Can you figure it out? How many missing numbers I have? Can one of you say? There are 9 missing numbers, right? And which are, see, after you see this, can you tell which column has the highest missing numbers? Which column has the highest missing numbers?
RBC.
RBC has got the highest missing numbers. It's 131. Sorry, RBC, not red blood cells, not RBC count. RBC has got the highest missing numbers. All right. So I told you 2 conditions are very important. All right. You should not have any, you should not, when you want to develop a machine learning algorithm, your data set should be converted, everything should be converted into numerical values. That we have not done, that we'll be doing it. And next step, you should not have any missing values. You should not have any missing values. One cell also should not be missed. There are several methodology to work it out, like imputations function, imputing using mean, median, most frequent, mode, because that all comes under feature engineering. That's a very big topic. So I'm not going deep into it. So what I'm going to do, I'm going to drop the rows that contains missing values. Okay, so that is what I'm going to do for the session today. So df dot is null of dot sum of, I'm able to find it. So I'm going to use this function dot df dot drop na. Df drop na. I'm going to assign that drop variable to another data frame called as, another data frame called as df1. Okay, so df1 dot drop na. So when I see df dot shape, it is 400 into 25. So df1, I'm assigning my drop na to another variable, another data frame called as df1. So from 400, it has reduced to 158. Can you find it out? Actually, I cannot, there are different imputation functions available. Okay, I've done it for this, but I'll not be able to, I can just show you, but not demonstrate. All right. And here I can use an imputation functions. Okay, imputations, like I can fill the null values either using random samples. Okay, randomly I can take any value and assign it, or else I can use a mean, median, mode function of it. Okay, the mode of the value could be replaced with it, and then we don't. So there is a lot of imputation functionalities available. We are not going into that. To make it easier, I'm dropping all the rows that contains. Okay, after I dropped the rows, now I'm going to, so it is into the new data frame called as df1 dot is null of dot sum of. Okay, now can you see, is there any missing values in df1? df had missing values. Whether df1 has missing values? Yes or no? Yes or no?
No, ma'am.
No. So I'm dropping all my missing values. The function is df dot drop na. So this is the function to find whether any missing values is null of dot sum of, and df1 dot, what do I do? Drop na. Drop na. I'm assigning to a new data frame. My df data frame will contain the same data set with null values. My df1 will contain the data set with not null values. All right. Are trying it now? df1 is equal to df dot drop na, and then try df dot shape and df1 dot shape. Have you got a new data set? Okay. Okay. And now I told you two things, right? One is you should not have any missing values. We shall need, yeah, you need to define, just give df1 equal to df dot drop na. df1 equal to, so the entire data frame will be copied to another data frame df1. So furthermore, we will be using df1, not df, because df contains missing values. So what I'm going to do, I've got categorical values and numerical, categorical columns and numerical columns. You remember I told you need to convert all your categorical values into numerical values. You need to convert all your categorical values into the numerical values. All right. And here wherein I'm converting, I'm using a for loop. Everything in Python is indent. You don't have open or close parentheses. Okay. For call and cat calls is a variable that contains a list of categorical names. I'm printing call, that function name call has, okay, red blood cells has how many categories? 10 unique categories. So 2, everything has got 2. Okay, I have to convert all the categorical values into numerical values. I hope you remember when I told you the step of machine learning. Okay, you need to convert your categorical values into numerical values onto the steps, right? Onto the steps of your machine learning algorithm. See, define the problem. You have got the benchmark data set. We are doing the exploratory analysis using NumPy, Pandas, Matplotlib, Bokeh, Plotly, missing values. We have completed that when we have deleted or dropped the missing values. Now we are into this step of converting categorical values into numerical values. So for that, it provides a package called as label encoder. I mean, everything in Python is a object. So label encoder is equal to le.label encoder of. Okay, I'm giving all the categorical columns and I'm converting df1 dot call is equal to le dot fit transform of that categorical values. Once I've converted using le dot fit transform, can you see all my columns? All my columns are converted. It takes its own methodology of converting into zeros and ones. Okay, after I converted, can you see it's all converted into zeros and ones? Data frame 1. Can you see? And also it doesn't contain any missing values. Okay, this is how we'll be doing it. Okay, in the afternoon session, we'll start with the label encoding. Okay, from sklearn, these are the pre-processing step. Import label encoder. L is equal to label encoder of for call and catch call. Okay, the categorical column which contains the list df1, which is equal to le dot. First, I'm importing the package, instantiating, and le dot fit transform of the column name in for loop, and it converts all the columns into this. Right. So in today's session, what we have seen that we reviewed what we have seen yesterday, and we started with taking the data set, loading the data set, and predominantly we saw different visualization of count plot using Seaborn. All right, and then we went into Plotly where we saw about the bar graph, the scatter plot, the violent plot, the kernel density plot. For one columns we have done. I wish you to try for different other columns. And then we have worked with missing values. We have figured out the function, how to find missing values, and also missing values visualization we have seen, and we have dropped it. We have not gone into the imputation function, but rather we dropped it and we created a new data frame df1, and now we are converting. First process is over. The second process is converting your categorical values to numerical values. Till that we have completed now. All right, the remaining we'll see it on the afternoon session. Over to the organizers.
Thank you, ma'am. Thank you so much for a very enriching session. And request to participants for the afternoon session, kindly join on time, and please join with your laptop so that you'll be able to work it out. I think some of you would have joined through your mobile, so that you'll not be able to do the hands-on session. So kindly join with your laptop so that you can do whatever ma'am is telling us. Thank you, ma'am. Thank you so much. We'll resume by tomorrow. Thank you.
Okay, thank you.